Once upon a time, there was an alien nation from the moon. He was looking at the planet Earth, staring at it like he wants to go there. The alien was always asking this kind of question.
What is the theory that tells the human about law of nature in the earth?
Luckily, he caught a human who has a knowledge about the topic. He decided to ask her to satisfy his intellectual curiosity.
Hi guys, I am Cham, a teacher from Edison University. In order for you to understand the Albert Einstein's theory of special relativity, first let's watch this video. Albert Einstein's special relativity. Einstein explained that when two objects are moving at a constant speed as the relative motion between two objects, instead of appealing to the ether as an absolute frame of reference that defined what was going on. If you and some astronaut Amber are moving in different spaceships and want to compare your observations, all that matters is how fast you and Amber are moving with respect to each other. Special relativity includes only the special case, hence the name, where the motion is uniform. The motion it explains is only if you are traveling in a straight line at a constant speed. As soon as you accelerate or curve, or do anything that changes the nature of the motion in any way, special relativity ceases to apply. That's where Einstein's general theory of relativity comes in, because it can explain the general case of any sort of motion.
Einstein's theory was based on two key principles. The principle of relativity. The laws of physics don't change, even for objects moving in inertial frames of reference. The principle of the speed of light. The speed of light is the same for all observers regardless of their motion relative to the light source. Physicists write this speed using the symbol c. The genius of Einstein's discovery is that he looked at the experiments and assumed that the findings were true. This was the exact opposite of what other physicists seemed to be doing. Instead of assuming that the theory was correct and that the experiment failed, he assumed that the experiments were correct and the theory had failed. In the later part of the 19th century, physicists were searching for the mysterious thing called ether. the medium they believed exists for light waves to wave through. The belief in ether had caused massive things in Einstein's view by introducing a medium that caused certain laws of physics to work differently depending on how the observer moved relative to the ether. Einstein just removed the ether entirely and assumed that the laws of physics, including the speed of light, worked the same regardless on how you were moving. Exactly as experiments and mathematics showed them to be.
Einstein's theory of special relativity created a fundamental link between space and time. The universe can be viewed as having three space dimensions: up or down, left or right, forward or backward, and one time dimension. This four-dimensional space is referred to as the space-time continuum. If you move fast enough through space, the observations that you make about space and time differ somewhat from the observations of other people who are moving at different speeds. You can picture this for yourself by understanding the thought experiment depicted in this figure. Imagine that you're in a spaceship and holding a laser so it shoots a beam of light directly up, striking a mirror you've placed on the ceiling. The light beam then comes back down and strikes a detector. Top, you see a beam of light go up, bounce off the mirror, and come straight down. Bottom, amber sees the beam travel along a diagonal path. However, the spaceship is traveling at a constant speed of half the speed of light, 0.c as physicists would write it. According to Einstein, this makes no difference to you. You can't even tell that you're moving. However, if astronaut Amber were spying on you, as in the bottom of the figure, it would be a different story.
This strange behavior of space and time is only evident when you're traveling close to the speed of light, so no one had ever observed it before. Experiments carried out since Einstein's discovery have confirmed that it's true. Time and space are perceived differently, in precisely the way Einstein described, for objects moving near the speed of light.
The aliens had a great day learning Einstein's special theory. They were sad to see Miss Chen go, but they couldn't help overcoming the happiness about all they had learned. The